right, linear approximations. Let's start this twice. I don't feel too good today, but you have to do it. Okay, let's see. Let's see if we can find a linear approximation to these functions at the given points. So f of x equals 3x times e to the 2x minus 1. We're going to differentiate f prime, and we'll use the product rule. So that should be 3e to the 2x minus 1, differentiating the first function, leaving the second one alone, plus now differentiate the second function. All right, so a 2 comes into the front, so it should be 6x e to the 2x minus 10, just like that. Now, what we're going to do is we're going to find f of 5. So that should be 15 times e to the 10 minus 10. That's a 0. E to the 0 is just 1, so it's 15. So 5, 15 lies on f. And the tangent line to f at 5, 15 oh darn it, I forgot to figure out what the gradient was at that point. So f comma, we'll input 5. Oh, actually, I think we could do this, just simple values. So 5 up there, so that's just 1, and that's 1 as well. So 3 plus 30, so 33. So 5, 15 lies on f, and the tangent line to f at 5, 15 has a gradient of 33. Use y minus y1 equals m, open brackets, x minus x1, and just plug everything in. Or I should really start remembering it as y equals y1 plus m times open brackets x minus x1. Anyway, so there's my x1, there's my y1, and there's my m. All right, so 15 over here, plus symbol, 33, open brackets, x minus, and then a 5, just there like that. And then planing it up fully, y equals 33x. So that would be minus 165 minus 165 plus 15 is minus 150. Just there like that. So that should be good. All right, so I guess the notation, so I'll do this in red just so it sticks in my mind better. I guess we use capital L for a linear approximation. It's really just a tangent to the function at that given point, isn't it? Next one. So we'll just literally just compute h prime of t. All right, so that's 4t to the 5. No, 4t cubed rather, minus 18t squared, plus 3t, just there like that. Now, let's compute h of -3 and then h prime of -3. Okay, so -3 cubed is -27, times that by 4, and we get -108. And square -3, and we get 9. 9 times -18 is -162. And then we get -9 there, just like that. Put these together, we get -270, so -279. Now, that is totally wrong, because that's actually h prime of -3, beg your pardon. That should be down there. If I did this even correctly, so cube it, that should be negative. That should be negative. That should be negative. All right, so I think that's okay. As for h of -3, well, we need to sub in -3 here. So -3 to the 4 is 81. -3 cubed is -27, but times that by -6, and we get 162. Try again. Yes. -3 times it by 3, and then take 7. So that's 243. Then you need to take 243, take 9 is 234. 234 take 7 is 226. So I believe -3, 226 lies on h. And the tangent, which is really or as they call it, the linear approximation, to h of t at -3, 226 has m equal to -279. Use y equals y1 plus mx minus x1 and just plug everything in. So 226. That should be actually minus 279. X minus 3 minus x minus minus 3, so plus 3. Then calculator assistance. Oh my goodness me, I've just realized how massive I actually am down in the corner. Is there any way to reduce the size? Well, I guess not. I guess I'm just intrinsically massive down there in the corner. Do you know what? I'm going to have to do this. For the sake of it recording everything, I'm going to have to actually move everything over, aren't I? Even though my brain isn't used to it, you know, tough luck. You have to just get used to things. Yeah. Although then, if it doesn't have enough scroll room down there, that sort of happens. So how am I going to fix that? I'm just investigating how much room this actually takes up. Well, that's my best attempt to fix that. Anyway. Okay, did we get these numbers right? Nope, because we tried doing it by ourselves, didn't we? Darn it. Okay, h of -3. -3 to the 4 is 81. -3 cubed is -27. Times that by -6. That is 162, isn't it? And that is -9. And that is -7. But I guess we're going to have to check. No, they're completely right. It's 227. Oh, look, I'm only off by 1 unit. Don't know why I didn't catch that. Okay. Now this is totally wrong. So let's see. -27 times up by 4. Yeah, it is -108, I think. 9 times 18 is that. So again, am I computing this wrong? Minus 270. So I don't see how that's wrong, but okay, so I'm just gonna have to disagree with him. But then he said +3. And that's where I got it wrong. See? That goes to 3. Just inaccurate. Okay. That's a 3. That's a 3. So correct it now. So minus 267. All right. Times up by 3. Minus 574. Okay. Seems accurate. Now, Find the linear approximation to g of z at 4th root of z. Find the linear approximation to g of z, which is the 4th root of z, at z equals 2. Use the linear approximation to approximate the value of the 4th root of 3 and the 4th root of 10, and compare the approximated values to the exact values. All right. So, first, we state that g of z z to the 1/4. G prime of z is a fourth of z to the minus 3/4. G of 2 is 2 to the 1/4, which is approximately I will never ever understand why people get motorbikes that sound as if they don't function. What is the appeal? I mean, people can do it if they want, and they will. But just what is the appeal? There's the linear approximation. L of the 4th root of 3, and we need to compare that to G prime of the fourth root of 3, I believe. Right? So I'm going to type in 0.14865 times 4th root of 3 plus 0.891905, and I get approximately 1.087539. And while I'm here, I'll do the 4th root of 10. And I get 1.156246. Okay, so G prime of the 4th root of 3. Let's think about that. So that's 1/4 that 3 to the quarter to the negative 3/4. Okay, so obviously this computation is wrong. Obviously it's wrong. And I don't see why. I'm just get fed up with these arithmetic errors. Anyway, let's see. Let's start the solution, all right? Oh, look. Oh, look. He's going to do it in exact form. Fine. That's fine. I'm totally fine with working in exact form. That's the way you want to do it. That's the way you want to do it. Two to the 1/4. So That's a quarter times 2 to the 1/4. Is it not? Right? There it is. Now, oh, I get it. Oh, I get it. I get it now. Now we need to quantify how large of an error this actually is. Right? I mean, I want to actually know what percentage of an error that actually is. So let me think. If I guessed 1.5 and the actual value was 1, the error, logically speaking, is 50%. Right? So what do I have to do to compute this? You tell me. Divide that by that, take 1, and times it by 100. So we're going to say 1.337858004 divided by 1.316074013. Take 1 times by 100, and that's a 1.655% error. For 10, exactly the same story. 2.3784143 divided by 1.7782791. Take 1 times by 100, and we get 33.748%. So a much bigger error. Let's check if that's right. Okay, that's good. That's correct. All right. What now? Find the linear approximation to f of t, where f of t equals cosine of 2t and t equals a half. I use the linear approximation to find the values of cosine of 2 and cosine of 18. All right. D by dx of sine of x is cosine of x. D by dx of cosine of x is minus sine of x. So minus 2 times sine of 2t, right? And wait, sine of 1, we don't know. Okay, what now? F of a half and f prime of a half. F of a half is cosine of 1. Let me guess. Exact form, right? We'll put it in approximate. You know, so we can say that it's done. All right, and then that should be negative 2 times sine of 1, which is approximately negative 1.68294197. Okay, so what's the linear approximation then? It should be, let's think. So a half comma cosine of 1 lies on f of t, right? And the gradient at a half, approximately, as far as we know, is minus 2 times sine of 1, is it not? So cosine of 1 plus, or rather minus, because of that, open brackets, x minus a half, just like that. Okay. Now, we're supposed to use this to approximate the value of cosine of 2. Okay, so that means what? L of 1 if I'm not mistaken. So let's get the approximation first. Whereas the actual value of cosine of 2 happens to be closer to this. Now, did I do that right or not? Okay, that's totally correct. So is that. Good. There's my L of t. Oh, beg your pardon. That should say t. And now he chooses to approximate. So I guess he just does it whenever he wants. Whereas before it was all in exact values the entire time, but whatever. Yes, it is approximating f of 1 for that. So he just plugs in f of 1 and gets that, plugs in L of 1 and he gets that, and that's good. That's exactly what we thought. But I don't see anything for 18. Okay, that would be L of 9 versus cosine of 18. I think these are going to be completely unrelated, essentially. Just nothing to do with each other. So cosine of 1 minus 2 times sine of 1 times 9 minus a half. And we do that, and we get minus 13.7647044 versus cosine of 18, which is way off. Way off. And I will actually compute their errors now. That divided by that, 0.30116866789 divided by 0.416146835. Take 1. So it's a negative 27.629. Apparently. But let's see. How does he calculate? Okay, then he finds the absolute value of it. But I think having a sign is an advantage because you get to see what direction the error was made in. And of course, this one is absurdly high. Colossal. Because these are sinusoidal functions, and so they're sort of bound within a range. And so using a linear approximation for a great big value that's really, really far away from where you took the approximation is stupid. Very stupid indeed. It's not going to get you anywhere close to the answer. All right. Fifth one. Without using any kind of computational aid, use a linear approximation to estimate the value of e to the 0.1. No computational aid. Okay. Why am I meant to do that? E to the 0.1. Just say nope, that's not going to work, is it? Mm-hmm. Mm-hmm. Don't know what you're talking about. I do not see how linear approximation will help me get that. Don't see. Okay. If I do this, course hits itself. For sure. But so what? Okay. L of x is what, this? Nothing to do with it. Nothing to do with it. What? And then you just this doesn't work at all. You plug in that and then they cancel out and then you just back where you started. So tell me how you start. Okay, got that. Zero. Okay. I know that it's going to be extremely close to 1. Absolutely anybody on Earth knows that. But it's can you do better than that? That's it. All right. I guess I could have done that. 1 plus 1 times x minus 0 equals x plus 1. Okay, now to see if I actually understand that, see if I can recreate it. We'll use Lx of this at this. As f of x equals e to the x, then f prime of x is equal to e to the x, and at f of 0, now f of 0 equals 1, and f prime of 0 equals 1. So the linear approximation is y minus y1 equals mx minus x1. We move the y1 over here. So that is 1. Oh no, I'm getting confused. Hold on. Okay. That should be a minus 1. Y minus y1 minus 1 plus 1. No. Darn it, I'm getting confused about this. 1. 0. Minus 0. What? Okay. Just keep it together. I'm going to have to write it out. Otherwise, it's going to annoy me. Y minus y1 equals m. X minus x1. Y minus 1 equals, what's the gradient? 1. What's the value of x? Well, doesn't matter. I see. So just that. So yes, so 1 is the approximation. Right, I get it. Moving on. Average function values. This is in integration. Okay, so let's just see if we can do it. Integral of 8x minus 3 plus 5 e to the 2 minus x dx from 0 to 2 and divide all of that by the width of the interval, which is 2 minus 0, which is 2. So what is this? That's a half of, integrate that, 8, no, that's differentiation. There, and now this, there. Calculate. So could have done that all in my head. Should have done that all in my head. Just getting used to the calculator. Okay, got that. Right? Well, only one way to find out. Check. Okay. Great. So he did it in exact form. Just does whatever he wants. 0.5 times 5 plus. Correct. Substitution for that. All right. Okay. Second one. Integrate f average over that. So what's the width of the interval? Pi over 2. No, totally wrong. 3 pi over 2. Yes. So 1 over 3 pi over 2. Should do that to show that you understand that. Minus pi over 2 to pi and integrate in a second. What's the reciprocal of that? 2 over 3 pi. What's the actual integral of this? Sine. half of sine 2x. As for this one, cosine like this. And you should be able to actually put these in, right? Let's do it. Sine of 2 pi, what's that? 0. What's cosine of pi over 2? Cosine of pi over 2. Well, that's 0 as well. And therefore, 0 minus. What is sine of minus pi? 0. Okay. What is cosine of oh no. Oh no. Did you substitute in the first one wrong? Okay, begin again. Sine of 2 pi. That's 0. Cosine of pi over 2. That is 0. Okay, that's fine. Sine of negative pi. 0. Cosine of negative pi over 4. Um, 0 as well. Okay, this is one of his moral lessons where, or is it? Got that correct. Not going to catch me out on that. Got that correct. Okay, we're correct up to this point here. But oh no. Here comes the part where he's going to show me that I'm wrong. So I'm just going to put in the numbers. Right. Why isn't that correct, though? Which drives me insane, this whole exact value business. Sine of 2 pi. I'm so confident that's 0. Cosine of pi over 2. It is 0. And yet I can see a root sign. Just drives me nuts. It's designed to drive me nuts. Okay. Right, so where am I miscalculating then? First, okay, I'm correct about that. And I'm correct about that. Okay, so I did the upper limit. Totally 100% fine. Now, as for the lower limit, I know it's going to be this. I know it will be. Two times minus pi over 2 is minus pi. Still 0. Okay, so it's the very last one, isn't it? And that's minus pi over 4. It's that one. I know, Grippy. I knew. So if you knew, why didn't you do it correctly? It's root 2. It's root 2. All right, fine. I stand corrected. All right. So we get minus 2 root 2 over 3 pi, or so I think. But am I... No? Okay, that's fine actually now. All right. Problem 3. Problem 3. F of x equals 4x squared minus x. Okay, so that's the mean value theorem as applied to integration, is it not? So first we're going to find f average. So what's the width of the interval? The width is 5. So 1 over 5. But you know what? I'm going to write that. From -2 to 3 of this. Just a bit more of the ones that I have. This that that's my part A. My part B is to determine the value of C, that interval for which f of C is equal to the average value. Okay. That hinges upon the average value being correct. Oh, thank goodness. Okay, so is it not simply the case that I can just say f of C equals 4C squared minus C plus 5 and set that equal to 83 over 6 and then solve? Maybe, maybe not. We're going to see. Using the quadratic formula. Minus 1, 1, plus square root of 1 minus 4 times 4 times Okay, so I get this. 616. Do not worry. I know that we have to be within that interval right there. So when I do the next step, I may check by that. Good, they agree with me. And let's see. Oh, thank goodness. All right, okay, that's correct. Whew. Okay. Let's see now. Where are we? Okay, we did average function value. Right. Area between curves. But there are some other notes that I really want to read about complex numbers. You'll never get there unless you actually do the things that you don't know how to do. And therefore, new thing. Whether I like it or not. So, possibly add on something. area between curves. There. And continue. Oh, look at that. ABC. Area between curves. Okay. All right. So let's just do problems 1 and 2. Oh, here comes a noise machine. Motorbikes designed to be noisy for no reason. So determine the area below here and above the x-axis. All right, so if we just do, think. It's a parabola, and so we need to find the roots of the parabola. Like that, right? Okay. At least try to do it in your head. 3 cubed is 27, so -9. +9. +9. -3 minus 1 2/3, so +1 2/3, so 10 2/3, or so I believe, but soon we'll see. Yes, that's right. Okay. Determine the area to the left of g of y equals 3 minus y squared and to the right of x equals -1. Okay, so right? Yeah, you could do that, but why don't you just move the whole curve to the right by 1 unit? That would be simpler, right? Oh, man. Now, g of y, really, it's saying this, isn't it? And you just go in where x is, and you have to do this. That's right, isn't it? Well, hold on. Yeah. 4 minus y squared. Yeah, it does do that. That's what I thought. I don't know how to articulate this, though. I know what I'm doing, but it's 4 minus y squared, and that obviously intersects the y-axis at 2 and minus 2. So it's really this, isn't it? Like that. Anyway, 4y minus a third of y cubed, and go from minus 2 to 2. You do that, don't you? First, Do we even get the answer? We do, but let's see what he did. Okay. Right, okay, so he ends up doing what I did. All right, okay. Not sure if this technique will actually last long. So let's see. All right, problem 3. Determine the area of the region bounded by the given set of curves, y equals x squared 2 and y equals sine of x. Here to here. Okay. So I want to get a mental picture of what it looks like. X squared 2 is just the unit parabola but raised by 2, isn't it? And sine of x happily sits underneath. Something like that. And I mean, it goes to the left as well, but I'm not interested in that. Oh, yes, I am actually, from -1 to 2. Okay, so let's think about this. Right, just carry on until you get there. Okay, so what am I thinking? Like that. -1. Okay, so pi over 2 is 1.5-ish, pi over 4. So -1 should be there-ish. And 2 should be there-ish. And that's what I'm interested in, right? That region right there. Okay. So how I'm going to do this. Okay. So split it up first. This will be useful. There. Whatever this happens to be. 8 over 3 plus 4 which is what? What? 2 2/3 plus 4, so 6 2/3. Six and 2/3. 6 2/3. 6 2/3. 6 2/3 plus 7. Darn it. What's that? There. Plus that. Yeah, right. Okay, fine. 9. Okay. Now, compute that little bit there. Okay. Ugh. Not yet. All right, that makes no sense at all. That should be positive, shouldn't it? So why is that coming up like that? Because of that. And now this part, but render it positive, is it not? Right? I guess so. It won't make a difference, but so it's these added together, is it not? And if it's not that, then I want to know why it's not that. First, just see. Anywhere close. Okay. Right, okay. No, that's fine. That's fine. Oh, I know why. I know why. Because you're supposed to do that minus that and then plus that. So, with one minor modification, I can correct it. And I get 8.043, which is right. Okay, so it's just a minus sign. But now, see what actually happened. All right, so my way of doing it was stupid and took a long time. And so what should really be happening is something like this. Something like this. Minus 1 to 2 of x squared plus 2. What does he actually do? What does he actually do? He just takes one function away from the other and goes between the limits because they don't intersect, so it should just be totally fine. So that's the real way to do it. All right. I understand. That's more efficient. Okay. Henceforth, that's what I'll do. Next. Next up is this one with a reciprocal function and a linear function. But what does that look like? Y equals 8 over x will look like this. And y equals 2x will look like this. And we are to do it I see. Okay. All right. X equals 4. Well, x equals 4 is a vertical line. And I don't know where it will be. Maybe here. Don't know. Don't know. And so perhaps they're asking for something like that. But let's find out. Let's find out. So that's that one. 2, 4. And x equals 4 is this guy, isn't it? And so, what are they really asking me for? They're asking me for this weird weird slice right there, aren't they? 2,4, that's him. This one is 4,8, and this one is 4,2. Oh yes, it must be, because it's on the reciprocal thing, isn't it? Okay, so how to obtain Pinky? This one. How to do it? All right, what I'm going to do is get the area of the triangle and then take away the area that I'm going to call orange. Make sense? Makes sense. And because that there is 4,8, that actually gives me enough information to find the triangle. So how can I actually indicate that? Area of triangle OAB equals half of 4 times 8, which is 16. Fair enough. Now, just call it alpha. Oh no. Oh no. Oh no, 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 no. I just realized it's not as well behaved as what I thought. So I'm going to split it. Hold on, a motorbike. Good. So I'll split it into 2 pieces down there. And I get the piece on the right by doing this. 2 to 4 of 8 over x dx. That's on the right. Plus, that guy there is 2,4. So it's really just 2 times 4 over 2 is a naught. And there you go. Now, how to actually get this? What's the integral of 8 over x? Well, it's 8 ln x. Right? Let's see if that's even close to being correct. Okay. He has my region. Oh, yay. It's actually right. All right. Right, let me try a fifth one. Fifth one. 2 parabolae and two horizontal lines. Two parabolae, one opening to the right and one opening to the left. And just do it. Okay, so let's think about it logically. What is this going to actually look like? Like, we know that x equals y squared opens up to the right. We know that. But what happens when you say x is equal to 3 plus y squared? I do not have a word for it, but I know that it moves 3 units to the right. But how do I describe that? Well, just think about logically, what actually is this 3 doing? It's contributing 3 to the horizontal position of every single point. So they all go 3 to the right. It's like they're marching, right? So like this. That makes sense to me. 3. All right. Now, what is this? Well, it's opening up towards the left, but then it's 2 units towards the right. And so it should be here at 2. Now, what does it mean when we say y equals 1 and y equals negative 2? We're talking about there and don't know, do I? Could be there. In fact, so that is an accurate drawing and it doesn't mislead me, I'm actually going to go out of my way to find out what those roots are. You know? So, plus or minus root 2. Makes sense. That makes sense then. And that would make sense then. So at the very least, I understand the question. Now, because they don't intersect, it was agreed that the more efficient way to do this is to simply subtract the functions one from the other. Right? So, let's see. We're just going to do it. And if it doesn't turn out to be right, then so be it. We learn from it and improve. Negative 1 to 1. That, take away that, dy. Negative 2 to 1, rather. Okay, so I shall do this. Okay, plug in 1. That's just 2/3 add 1, which is 5/3. So that's what I think. But now we'll see if it's right. Okay, that's good. All right. And they thought the same. Okay. Right, I can close the window now. Stop the sounds from coming in from the outdoors. Okay, so what actually is this? Well, it's a parabola that's opening up to the right. And that's a straight line function. So we need to find out if they miss each other. Yes, they do. No, they don't. No, they don't. Beg your pardon. That was wrong, what I just said. So, what is it actually talking about? You know what? I think it's going to be like this. And then that thing there, whatever that is. Which looks like a nightmare. I mean, it should be really, really simple, right? Yes, it should, but the only way to actually get there is to just try it and do it. So how to do this? Get a better idea of what the actual function looks like in the first place. So, there and there. Wait, what? What? No, 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 no. Hold on, hold on, hold on. It crosses at y equals -2. Did you see that? Right? So it's going to be up there. And of course it does, because you put in -2 into, where is it? Into here. And then you get 0. That makes total sense. So it's this guy. So it's not actually so bad, is it? Really not. So we just have to figure out that, and then it's still really bad. It's still really, really bad. There must be a more efficient way to do this. I mean, it's just so dumb. Like, just adding up all these tiny little jigsaw pieces. There must be one method that just really is efficient. And I'm just too foolish to think of it. Regardless, just make do with the tools that you have for now. Yep. Okay, so I can definitely get that blue area right there. And of course, I could also get that. And I could get that and then take that away from there. But this, it's just so roundabout, and it just takes such a foolishly long time that I'm so sure that I'm going to be shown a better way in just a moment. But for now, just do it. All right. So -2 to 3 of who? Y squared minus y minus 6. Gotcha. And actually compute that integral. So 3rd of y cubed minus half of y squared minus 6y from -2 to 3. Okay, fine. Now, for this guy. Now, do we know what that point is right there? We do. It's 5. That doesn't actually help you. That doesn't actually help you. All right, we want to learn what is the better way to do this. So my prediction is, what's my prediction? That I'm not sure, but there has to be something which just very procedurally involves subtracting one from the other or something like that. You know what? I'm going to make this my mission right now. The area between a parabola, just any parabola, and a straight line. Okay. So they go from that intersection point to there. Excuse me, that's not 5 down there. That's totally wrong. Totally boneheaded and wrong. That's actually 5 over here. Don't you see? So, minus 2 to 5, linear, minus the quadratic. And I get that, and if they were to do it the other way around, then it would just be a minus sign, right? Right, okay, so that's way better. Way better. I thought it would be something like that, but anyway. All right, let's actually do it. Okay, so first, finding intersections. So what we do is we just set them equal to each other because they're both equal to x. So y squared minus y minus 6 equals 2y plus 4. Just like that. Y squared minus 3y minus 2 is equal to 0, just like that. So y minus 2, y minus 1. No, that's totally wrong. Totally wrong. Okay, now I lost it. What was it? Minus 3y. Oh, minus 10. That's it. Oops. Now we go from there to there. And right. just plug things in. So I've got that. And that. And that's good. That's good. Okay. So I'll probably have to go to visit the bathroom after this 7th one or something. Oh no. Oh no. What an absolute oh my goodness me. There's no way. I mean, I think this is more difficult than the other ones. But anyway. First, what does this function look like? Okay. E to the minus a half x. Like that. No clue what this looks like. Really, I don't. The thing is, if they miss one another entirely, I mean, it might be fine. But hold on just a minute now. No, I got nothing. That's always positive, and so we can always take the square root, and so that's always positive, and x is sometimes positive, sometimes negative, and so it should pass through. It should be. I don't see how it's not like that somehow. bottom left to top right. So figure out where, just plug in 0. Oh, look at this. Plug in 0. Now, when you plug in 0, what do you get? You get y equals 1. So 0, 1. Whereas when you plug in 0 here, you get 0, 1 as well. And that's going to increase and go past that guy. I don't know what the curve will look like exactly, but I think something like this. All right. And now what's going to happen? Figure out when it's equal to 0 itself. One or both of them would have to be 0. Oh no. Oh no. No. No, 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 no. That's completely wrong. Totally wrong. Totally wrong. That's 0, in fact. All right, so I was wrong. And so now I must be unwrong. It'll be like that. There, like that. Maybe something like that. Don't know exactly. X is equal to 3. Well, that's a vertical line and the y-axis. All right, so now at the very least, we now have some clue about what's actually being asked of us. Beg your pardon, that should be coming out there. Oh, that's terrible. Right. Even worse. The point is to show something like that. And it's wrong as well, because it's x equals minus 3. Oh, man. All right. Okay. There. On the y-axis. Okay, so now we have some clue. We're being asked to find this. So how to do that? How to do that? Why don't you why wouldn't this work actually? From -3 up to the point of intersection of these two, whatever that happens to be. So let's solve that. We'll solve it, but I just want to say that it's going to be e to the minus half x minus this. That's what I believe, but let's just work out the upper limit of integration, yeah? So solve when they actually meet. So e to the minus half x is equal to x root x squared at 1. Now if I take natural logs of both sides, I get minus a half x equals ln. I can't solve that though. Can't solve it. Don't know how. Don't know how. Don't know how. Don't know how. So I'm curious. Oh, that's because I'm in error again. He wants it between x equals minus 3 and the y-axis. So no problem at all that I don't know how to do that because I don't have to know. So let's just recover. No, -3 to 0. So why is it not this? Could be this. Let's see. That I can integrate. That I can, but I need to handle them separately because I need to do substitution for this one. Come on, I've done it a million times. Don't know why I keep forgetting this. Right. Gotcha. Like that. Now for this one. Okay, that's all fine and good, but did you handle the limits? No, you did not. Wrong. It's wrong. Two-thirds. No. Ugh. What did I even do those limits for? Hello. Whoops. Right. U to the half, u to the 3 over 2, 2/3 of u to the 3 over 2. There. Right. Let's just check and see if we're even close to being on the right course. Okay, so he does what I do. He integrates it and he gets that, and I like that. And then he integrates this and he gets that, and those would indeed make a third, and then he goes from there to there. All right, so that's more I want to try out that notation. E to the minus half x minus a third. Like that. A big bar, vertical bar, -3 to 1. All right, so plug in 0. And that should be fine because that's going to be 1. So it'll be -2 minus a third. There's the upper limit sorted. Minus, and now plug in -3. So that we need the calculator for. So we get this. Let's see if that's right. Yeah, that is -7/3. And then he leaves it in exact form, of course. Plus the 19.5043. Yeah. Okay. Yes, I'll just pop to the bathroom. Right, be well.